Hello everyone, in this video we're going to continue working on electricity consumption data. In the previous video we did some simple data preprocessing on the data, and now we have a data set that has more columns and it's ready for more programming and analytics. So now we are going to look at the data from a different lens. We're going to be seeing if the data has missing values, which we did see has missing values. But in this video, we are going to see how best we can address different types of missing values. I mean, first we have to figure out what types of missing values we have. Then once we have that, based on the way we figure this out, we will see that. Then we will remedy those missing values and figure out how best to go about it. So yeah, let's look at the video. So as I said, we're continuing from the previous previous work we did. So we did a couple of different data preprocessing. We added a couple of columns. We removed a column that we didn't need. And then we got to a point that we saw we had around 60,000 missing values. So the very first challenge we have is we are going to see if we can use some visualizations to help us figure out if there are any patterns regarding the way these missing values happen based on the other columns. So we have this consumption column that it has 16,000 missing values. We're going to see if these missing values are happening on a specific pattern. And if that's the case, it's going to guide us through finding the best way to deal with them. So the way we do this, we use bar charts. So based on each of our columns, which were month, day, weekday, hour, and minute, we are going to come up with a bar charts that tells us, based on the unique values of each column, what are the propensity or like frequency of missing values based on each of those states. And that's done using this code. Basically, I'm going through each of these columns and I use that column to create a value counts, like how many times those values are happening based on the missing DF. And then I use the bar charts to basically create those bar charts. Now we can see that the missing values are happening everywhere except for month 12. That's one thing to remember. And then we can see, as far as the day, that sounds, pretty equal across the different days. We have 31, which not every month has 31 days, so it makes sense. And then on the weekdays, they're almost, equally happening. Also for the hours, but for the minute, we can see it's a very noticeable pattern that the missing values are happening at 15 and 45 minutes. Almost no missing values at 0 and 30 minutes. So that tells us what's happening really in the data is the fact that a lot of the times, I mean, in the beginning perhaps, the data were being collected by every 15 minutes. At some point, they must have switched to every half an hour. So since a lot of our data does not have every 15 minutes, so let's switch back to every half an hour and remove all of the 15 minutes from our data. So that's basically the answer to this challenge, and the best way to remedy this is to remove all of these 15 and 45 minutes and just start focusing on every 30 minutes data collections. So if I do this, now I create a Boolean mask and use the Boolean mask everywhere these are not the values I want to keep the data. So once I run this, now my data does not have every 15 minutes, it's every 30 minutes. And once I look at the data, now I can see that the number of missing value has dramatically dropped to 4. And it was 16,000. So most of my missing values were because of this inconsistency in the data collection. So let's do the same thing and sort of figure out if there are any propensities about these missing values happening at the time that we are seeing. So let's do the same thing. It's basically the same thing. Now I can see that there on month 12 there are 2 missing values, and on month 5 and 9 there seems to be a pattern on month 12, but it's not glaring, or it's not significant. It's just 1. If it was 3 or 4, and then it would say, okay, there's something about this month, but it's not that significant yet. And on days, they're completely scattered. On the weekdays, Mondays are 2 again. It's not that significant. Hours the same, and also minutes 2. So it seems like we don't have significant pattern of these 4 missing values happening at a specific time. Because of that, we assume that these missing values are happening randomly. And as you remember, the missing values that were completely randomly, we call them missing completely at random, MCAR. So these are MCAR missing values. So we can figure them out by seeing if we can find alternative or like substitute for them. So the best way to also investigate what's happening with these missing values is sort of like see the points next to them. So in this challenge, I'm going to draw line plots of 20 points after and before the missing values. So I'm creating a missing DF, missing all of the missing values, which are 4 of them. And I do a loop over all of these missing values. And then I get the data of 20 points before and after them. And I plot them. So once I run this, I will have 4 plots that shows me 20 points before and 20 points after these missing values. And I can see that these missing values are in the data, right, the visualization. So there are a lot of times that when you have a missing value, there are no ways or there are no indication of what this missing value could be. But that's not the case for this data. We have a lot of indications actually what this missing value could be. I mean, as we can see, this is a consumption data, and we do not expect this to fall down suddenly or rise up suddenly. So because we have a lot of data around this missing value, we could be using these data points to be estimating what this missing value could have been. And to do that, it's best to give a lot of weight to the closest data points and less weight to as we get further from the missing value. So a common way to do this is to give 4 points to the points right before and right after the missing value, and 1 weight to 2 points before and 2 points after the missing value. So basically, the formula we could be using to figure this out could be something like this. Could be the estimate is equal 2 V 2 points before plus, so value 2 points before plus 4 times value 1 point before plus 4 times value 1 point after, and plus 1 point after, 2 points after, 2 points after. and divide this by the total weight. So you could come up with your own estimate formula. You can bring in the 3 points after and 3 points before and sort of like have different weights for them. But this is a fairly good estimate for these types of data. So let's go ahead and use this calculation to estimate these missing values. And it's very simple calculation. All you need to do is go through your loops of missing values and capture the previous 2 previous next and 2 next, and at the df at, which is the main data frame, not the missing data frame, and I is the index, and these are the same index because we filtered the missing df from the main df, and the consumption is the formula we just discussed. And once we run this, now we have taken care of our missing values. We can look at the report, see if that's the case, and also come up with the visualization that we had and actually see how they look like after we did deal with them. So this is the report. There are no missing values, and we can see that the missing value has been filled, and it's like it never was there. And it seems that this is a good estimate.